My final talk, spectacular lunar graze, observed last November here. First slide, or next slide. I should say at this point, permanent issue of this, grazing occultations, we've been observing them for since the 60s, I think David Dunham started the craze. The maximum number of events reported at a graze was is sort of in the low 20s. Regrettably, when I've had a look at any of those high number of event grazes of the older ones against modern lunar profiles, the actual numbers of events don't actually stack up. You find that a lot of the events must have been seeing conditions or bright limb stuff. I think the reputed maximum number in the past has been about 22, 23. I think for one of those, the real number was down around about 15. Anyway, and David might be able to say something more about that. Lunar grazes, well, as I've got a heap of you saw the Aldebaran graze the other night. Multiple events as the star skims along the lunar limb. When grazing was much more popular than it is now, we generated graze profiles, but there was a fair bit of uncertainty involved in them. The graze profiles were located for some location roughly close to where you were, and you sort of tried to position yourself where the events would be, and what you saw had a general relationship to the graze profile, but not very accurate. This has changed with the advent of data from the Kaguya and probably more importantly the LRO-LOLA missions, Lunar Reconnaissance Orbiter, Lunar, something or other, missions. Next slide. With the advent of the LOLA database, which has got a much greater density than Kaguya, we can now generate lunar limb graze profiles having a very detailed resolution, and it enables the observer to position themselves to observe a large number of events. And this provides enhanced opportunities to measure effects like stellar diameters, which you have with Aldebaran, or double star properties. Next slide, and this is where we have an experiment here. One of the important things, which what I'm talking about is quite important, is the graze profile varies along the path. And rather than going just to the closest part of the path that comes to your location, to maximise the number of events, you need to consider selecting an appropriate longitude along the path. Now, I've got attached to, on this, and hopefully Ted is going to be able to switch over to a different display to show an animated GIF image of a graze profile with showing the graze profile at half-degree intervals of longitude over about 5 degrees of longitude. We'll see how this goes. This might fail, but you'll also get an idea from this about the type of resolution we can now get with the graze profile. So look quite different to the types of profiles we had before. Okay, I'm seeing it on my screen here. And each step of there is a ½ degree change in longitude along the path. If you, for those who are looking at this on the screen, how do you do this? There's at the top right of the profile plot, there's a plus and minus sign. If you click the minus sign a few times, you get a smaller plot, and you can see the full Graze profile and see how it moves along around the different site longitudes. Also on that Graze profile, you'll see on the left-hand side, there's it's coming up here as a grey histogram bar down the side, which gives you an indication of the number of events you might expect at those distances from the nominal Graze path. And if you look at a location about almost 2 marks above the horizontal line, you can see how that is varying in number between a reasonable number to quite a large number. It's not so large there. Well, you can see how the number of events, there's gone quite large, where you're getting alignment with a rough area of the moon is relatively parallel to the Graze path. But that's probably enough. We go back to the main presentation. I'll wait for the thing to come up on screen. And we need to go to slide 5. That's it. So on November 17 last year, a good graze occurred close to my home. David and Joan had recently arrived in Canberra from Alice Springs. I'm not sure how many days they'd been here, but it wasn't, I think they just moved into the house they were renting in Canberra and hadn't packed. And on the night of this graze, we were located, it was Joan, David, then me, and the total distance between the two ends of us was 272 metres. Joan was able to get set up in time. We could only record the first half of the event because of increasing cirrus cloud. David got his telescope on the mount and wasn't able to get set up in time. It was just too much to do in the time frames. And I was able to get set up and observe through thin but increasing cirrus cloud, and I was able to record the whole event. Now, this is just a bit of an indication here where the predicted path was. My house is where it's marked home. Where the Dunhams were staying is marked there. That bean-shaped bit in the centre there, that's a region called the Australian Capital Territory. Think of it like Washington DC, but much larger. It's about 100 kilometres from top to bottom there, and most of it is nature park. And the white line going across diagonally is the nominal Graze path. Next slide. This was the predicted profile for this event. The red line was showing where Dunham's Dave Dunham's house was located. He was well outside the Graze path. My home was well inside, so we had to go to a place in between us. And you can see on the left-hand side the bars there indicating quite a large number of events. And that was about 4.7 kilometres in from the predicted edge of the path. When you're doing this stuff, you've got to make sure the graze path is calculated for the right site altitude, because that can affect things. Next slide. It would have been nice to show the YouTube video of this, but on this, but it's too complicated. If you write that down, you can have a look at the YouTube, the video that I recorded. The critical bit is the question mark V equals UCAP5 da 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 da. If you write that down, then you can look at the watch the event and the number of events that is apparent there on a superficial viewing. And when I went through it carefully, I almost doubled the number of events. So Ted, when you think people have had enough time to copy that down, you move to the next slide. All right, now that page is not readable on my screen here. That's a list of the results, and it's come up real weird. Main thing there is I recorded, what was it, 10, 20, I recorded 40, I think it was 49 or 47 events. And I was fairly certain of that because I was able to look at the brightness variation of the star versus the brightness variation of a very small mountain peak at the cusp, to make sure that it wasn't the fluctuations in the cirrus. A huge number of events, 40 something is sort of, it's not unheard of. Next slide. We're almost at the end of this. This, not easy to see on this. The dotted line there shows Joan's occultation path, and she recorded 5 events before cloud stopped her from seeing things. The star was moving from left to right. So you can see 2 events at the top of a peak, then 2 events at the side of a peak, and then a reappearance at the side of the very big peak. My events are a little bit further down, skimming across the top of the profile, and hopefully the next slide will show these events much better. Next slide. Yeah, I got 49 events, and yes, this is a clear presentation. The top one shows the first half. Where Joan got 4 events, I got 1, 2, 3, 4, 5, 6, 7, 8, 9 events, I think it is. And then on the reappearance side, where Joan got 1 and was clouded out, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, a lot of events as the star skimmed along the top of the file. It's a case of, if you get yourself in the right position, you can get observational data set. And the Kaguya, the LRO Lunar profile is of such good quality that it is sensible to do it. the early releases of it, the data density wasn't as good as it is now because the data set is increasing. But these days, the data is pretty reliable. Chris Douglas is asking what scope I was using for that. I was using a 20 centimetre or 18 needs Schmidt with a with this. I'm just trying to think what the video camera was. A normal routine video camera that I forget what the video camera was. Nothing particularly flash. Ted asked how far apart were me and Joan? 227 metres. Oh, Chris reminds me I was using the Waytec 120N camera. Yes, and I was. Yes, 200. Joan and I were 270 metres apart. We could almost call out to each other. And David was in between. And that's it. Any other questions? Apologies for my terrible pronunciation, but Wojciech Brzezinski has asked, could you put predicted number of contacts on bars or instead of bars as a cult of improvement? That's something I can look at to put a number there. The issue, the technical issue I have is the profile is plotted as a graphics image. And as a graphic image, it's very easy to scale it to different plot sizes. But if I to put a number in there requires some other challenges to get the plotting to do it so it's readable. And Wojciech has indicated that the Graze program apparently has that included. And they've recently released a version which uses the Lola profile. Any other questions? Derek is asking double stars and K2 occultations. One of the interesting things that has happened in the last 10 years or so, occultations up until 2005 the primary focus tended to be lunar down of the Japanese reporting facilities and various other considerations. People lost interest in doing lunar occultations. I think where there's been a bit of an overreaction to that, and there's definitely a place for us to pay more attention to doing lunar occultations. There are double stars to be measured and double stars Gaia won't be able to resolve, which only lunar occultations will be able to do that in the ecliptic region. And with the Kepler-2 mission, the K2 mission, issues of identifying close doubles or any other anomalies for stars which are being investigated in the K2 fields. Lunar occultations occur much more regularly than asteroidal occultations. And it is not the case that lunar occultations are no longer of any value. It's just that the value has changed. And it's not about measuring time or the rotation of the Earth. The issue is about looking at the stars that are being occulted at a spatial resolution of 10 milliarc seconds, which is what you get in a lunar occultation. And that's a resolution which you don't get with any normal earthbound telescope. So whilst most people have moved away from observing lunar occultations, I would encourage people to rethink that. It's a field of endeavour where you can get out and record observations, obtain light curves, report light curves, and have them properly archived at Vizier and contribute to measuring double stars and detecting stellar diamonds and all sorts of other issues. And so I'd encourage people to return to some focus to doing lunar occultations as well as asteroidal. Keeping in mind that asteroidal occultations are going to keep us very busy for the next several decades.
Dave, this is Roger. First, I want to thank you for your presentations, all of which were very interesting. We're all very indebted to Dave for the work he's done on the occult program, not only initially predicting grazes and occultations, but the updates he's made so regularly that have kept us abreast of the new science. And I'm just very impressed with his persistent work on occult, and want to thank him very much for that. I'm sure I speak for all of us. But I also want to just congratulate Dave for a record-breaking observation. Somebody has to say, wow. And so congratulations, Dave, for that wonderful graze that you just reported.